Good morning, friends and fellow Foundry enthusiasts. We are coming to you from ExOne GmbH, which is one of the leaders in the sand printing machine manufacturing out of Germany. And we have a significant presence in the world and in India. And today we are very excited to have Mr. Aldo Randazzo from the Engineering Center from Germany directly where we are trying to interview him in for the upcoming seminar that we are holding in India on the 25th of September. And we know Aldo very well, but for the sake of introduction, he is a very key member, one of the key members from ExOne, and with a lot of experience in the foundry and 3D printing. We will try to first we'll hear a little bit about 3D printing from Aldo, and then from there on I will start some questions which I would like to share in this telecast, if you will. Aldo, please introduce yourself and a little bit about 3D printing for our viewers in a very nutshell, please.
Yeah, thanks, Sanjay, also for invitation. So hello, everybody outside. So maybe I do a short introduction of myself. So I'm Aldo Randazzo. So I'm with the ExOne now since up to 7 years nearly. I'm working together with Sanjay on the Indian market, and maybe also visit you in a few of our journeys we did together, even on site on the market. I'm responsible for the whole application inside the ExOne. That means I really be going to the foundries together with Sanjay to really bring in the new technology of additive manufacturing and especially sand 3D printing, because this is what the foundry needs inside the companies, because we see a lot of benefits in this technology. But I think we will go during this interview a little bit more in details why. And I'm also responsible inside the ExOne company for the manufacturing center. So we have a parts on demand center, which I'm responsible for. Yeah, my background is I'm a foundry engineer, so I really know a lot of the processes which are taking into account into the foundry industry, and due to the possibility to see a lot of different processes worldwide, which are mainly used for the same production, I'm be keen to share information with you and can combine processes to help foundries outside to produce the best way.
Although for the viewers, 3D printing is a new technology, in terms of the fact that it's not something which is 100 years old. Maybe for the viewers' benefits, those who are not as familiar with 3D printing, would it be good to have a short introduction, printing by layer, and also then follow up the question. I would like to understand, for the viewers' benefits, what are the three major benefits that you see by using 3D printing process in the foundries, please?
Yeah, no, the good questions, but I will start a little bit earlier before I come back to the three main factors. I would say what I would like to say is at the beginning, because this is something I really see very often, and you too, Sanjay, is people think 3D printing is something totally different, which is absolutely new, but it isn't. Because if you look on the chemistry side, it's similar to what the foundries use today. Slightly different because maybe the viscosity in the process is different. If we compare, for example, with traditional core shooting, where you have some pressure and you are producing your core, but here you may have some limitations, because if you have a very huge core or some undercuts in the core, even the pressure cannot be high enough to really fulfill all the core areas. 3D printing is, in this case, the process, you're right, is totally different. So this is what maybe is new then for the Foundry, because we are really, as you mentioned before, printing layer by layer. So we are really putting one particle of sand on top of each other, glue that together with the same chemistry to make it easy, or to say it with easy words. But this special process, which works without any pressure, allows you to have also more freedom, because we can really place the particles inside the box where we need it and glue it together. And this is the big benefit we bring in with this additive manufacturing production. And coming back to your three major benefits, I think, yeah, as mentioned before, due to the process, the freedom on geometry, the complexity, and also the homogeneity of a core is more stable compared to a conventional core, because the pressure when you core shoot it or blast it will maybe different on each areas. This will not happening on a 3D printed core. So you have a very stable core. This is a big benefit. Yeah, the fast go-to-market production is also a big benefit I see with our technology, because we are working with files. We don't need a hard pattern or something else which needs to be created before production. We only handle with files, and everybody in the Foundry, you know, is talking about digitalization. We are really showing how digitalization works with our process and our technology. Yeah. And maybe last but not least, and this is something I see very, very important, is we have a very, very wide range of printing components available, so we can really easily switch and adjust the printer and the sand recipe and the cores on really what the casting part itself need, because I maybe don't need the same mechanical properties to produce a big casting part as I need it for a small casting part. And that can be customized very, very easily and fast with a 3D printer, which allows people to reduce the cost and be flexible.
Excellent. Would you also characterize that the fact the where you can have the freedom to put your chill pockets or your venting to reduce certain casting defects, which you would be having more freedom with 3D printing process compared to the conventional process?
Yeah, I think there are two main applications which explain very, very easy how 3D printing can really help the foundries outside. So, impellers is something everybody has nearly an impeller in his own production. Everybody don't like it because as more complex the part is, you have to stick it and maybe produce some single parts which then needs to be glued together because you cannot core shoot them. The thing is, when you glue some parts together, you will add in a new component which is given by the glue, and glue, when you heat it up, creates gases, and gases in the casting. Every foundry man knows that he don't want to have this inside, but here in this case we put it in, and even if you glue a core together, the mechanical properties are not so good as if you have a homogeneous printed core, or maybe a one-shooted core in one piece, because you always have a breakage line inside the glued part, which then maybe can end in a rejected casting part, and nobody wants to produce a scrap. Everybody wants to produce quality. We can really support in this case. Another big thing I really see is casting parts become more and more flexible or complex today. If I look on how channels today, maybe even for engine production and so on, looks like, you see it's not like the channel is only a line. It becomes more and more complex by having some circulation and something else. Here you need, after the casting, to maybe reduce the score, which we can help to to improve, because we can maybe print a shell core, which then maybe the chemistry burned away while casting, and then the sand flows out. So desanding is much easier. Or we can also help with using different sand types, which then maybe helps to flow out easy. And this is all something we can really help people to increase the quality of their own production. Yeah.
Excellent. We have been to many foundries in India, and in there we have also seen these common issues which you just spoke about, including a lot of workforce which is being used for gluing the small parts and making the complete core. I want to ask you a question where it will show that this technology is good for productivity, and yet we could probably utilize the manpower more effectively. That it works together with the manpower.
Fully agree. We have seen this in a lot of applications. I can remember on some visits, Sanjay, we had together, and then when we leave the company, we both think, oh, too much people working in the whole process. It's really crowded nearly, and maybe there is no need if you know how our technology can really help to avoid that. But let me start a little bit earlier, then I will come back to your question. So first of all, I want to tell the people outside that really 3D printing is not what they may be known from 10 years ago when we started to enter the market. So today, 3D printing becomes very, very fast. So we don't talking about printing a few liters per day. We become able with our new S-Max platform to really produce up to 600,000 liters or more per year. This is similar to a small or medium-sized core shooting machine. Or maybe with a printer, you can say you can also replace 1, 2, or 3 small core shootings machine, which is looking on the footprint of the company, absolutely interesting, I would say. The next point is when you compare the process with between a core shooting machine and a printer, when you core shoot a core, you need a worker which is always pressing a button, who then produces maybe 1 or 2 cores. He take it out, clean it. 3D printing is totally different. When you start printing a job, nobody is needed because the printer works alone. So nobody is really around the machine while doing that. This also lowers really the need for employees. And to be honest, so you can produce 24 hours with a core shooter. You cannot produce 24 hours without having any employee around. With a printer, you can. So and this is something I think which even people should take into account, that this in future I think will be more and more the type of production people are looking for to really lower the costs. All of that, the change of the employees are the work of the employees are changing, because they don't maybe press a button, they maybe empty a box which is printed, clean the cores, but within one of this boxes, maybe the benefit is given that they don't have a lot of post processes, because they only need to take it out, clean it very easily with a brush and air, and then the cores can be used inside the foundry to produce casting parts. It's not a big thing. And this is something I think will be the future. And I see, especially in Europe, where time is money and workers are rare. Yeah, this is something people look more and more to solve with our technology. And I'm nearly sure this will also happen one day in India.
Yes, we believe so. The productivity gains and the topic of productivity is also becoming extremely critical in a country like India as well. I come to you now for a question which is in the mind of everyone, of our viewers probably, and which is about cost. At the end of the day, it's always the dollars and the cents or the rupees or the euros, which really matters. So maybe give us a little bit of an insight from your side as to how you believe this technology is not going to increase the costs of foundries, who are going to adopt this technology.
Oh, this is to put this together in one point is very, very difficult because 3D printing has so much impact on the whole production process of the foundry. And for me, it's always difficult to scale it down to one point. But let me start with maybe an explanation. Look, today, when we go inside a foundry, Sanjay, the people always ask us, okay, what is the price for the production of a single core? But to be honest, I don't know any foundry which is really selling some cores. I only know foundries which are selling casting parts. So is it not interesting to know what's the cost for the production of a casting part instead of asking what is the production of a core? So this should maybe be the more interesting question overall. And this is something you can really influence massively with 3D printing, because 3D printing can really help to reduce costs even on the fettling or on the fettling side and on the post work which needs to be done on the casting parts. Because if you maybe can reduce the parts of single cores and merge it, you have also less flash lines on the casting parts, which maybe needs to grind away at the end of the day, which then saves a lot of money. Even on the printing side, maybe you be a little bit cheaper because you have less employees around. We discussed before. This will definitely lower the costs. Even you have, instead of maybe a 2-shift production, you will have a 3-shift production on this machine with less people which are needed for doing that, which will increase the productivity. I'm nearly sure that this will happen. So higher productivity will lower the overall cost for the production. And last but not least, I think we need to talk about a little bit about the resources which are needed for producing the parts and the cores. And what I see today, we are able to really print only maybe a shell core, which then will lowering the costs by only really print what you need. Why do I need a massive core for a small part and fill everything with chemistry? If I can save chemistry, material, and all the consumables, this also helps that I don't need to buy it. And if I don't need to buy it, this will save energy and money. And even, to be honest, and I'm an European, this is the future, because this will be green production. And this is something which also is needed in India.
Absolutely. Absolutely. So overall, it is a fantastic technology. You have the productivity, you have the quality, you have the sustainability, and you're moving in the direction where the world would like to see the foundries going. Would be really good to see you in the seminar. It'll be really good, and we are excited to have you here, and we look forward to your presence here. With that, I would like to close this this telecast, and thank you very much for your time. Looking forward to see you soon. Thank you.
Thanks, Sanjay. Nice to see you all. Take care, and we see you on the 25th latest.
Thank you.
Thank you. Bye-bye.
Thank you. Bye.